In the vast expanse beyond Neptune lies Pluto, a king of the Kuiper belt with a system of intriguing moons. Among them is Kerberos, a small dark moon discovered recently, adding intrigue to the Pluto system. Named after the three-headed dog of Greek mythology, Kerberos is a tiny moon, only a few tens of kilometers across. Despite its size, Kerberos plays a crucial role in the gravitational dance of the Pluto system. Imagine Pluto, a dim world, with Kerberos, a tiny sentinel, reflecting meager sunlight. What secrets does this small moon hold? These questions drive astronomers to study Kerberos. Hubble to the rescue. The discovery of Pluto's fourth moon. In 2011, astronomers using the Hubble Space Telescope found a faint speck of light, which turned out to be Kerberos. The discovery was unexpected, as previous observations hadn't revealed its presence. The Hubble Space Telescope's high sensitivity detected this faint object, demonstrating its remarkable capabilities. The discovery allowed scientists to refine the New Horizons spacecraft's trajectory for a safe passage. Kerberos, once hidden, is now a target of intense study, helping us understand the formation and evolution of our solar system. A diminutive world. Unveiling Kerberos's size and shape. Kerberos, a small and faint object, has an estimated diameter of 19 kilometers. Its irregular, double-lobed shape hints at a past marked by collisions and gravitational interactions. Kerberos's surface reflects very little sunlight, indicating a dark, possibly carbonaceous material. Despite its size and dim surface, Kerberos plays a crucial role in the gravitational ballet of the Pluto system. By studying these interactions, astronomers gain insights into the mass distribution within the Pluto system. A lopsided orbit. Kerberos dance around Pluto. Kerberos orbits Pluto at a distance of approximately 58,000 kilometers between Nix and Hydra. Its slightly eccentric orbit hints at the complex gravitational interplay between Pluto and its moons. Charon's gravity creates perturbations in the paths of the smaller moons, leading to their eccentric orbits. Kerberos's inclined orbit suggests a history marked by gravitational interactions and potential collisions. By studying its orbital parameters, astronomers gain insights into the history of the Pluto system. Kerberos's dark surface, even darker than charcoal, contrasts with its fellow moons, Nix and Hydra. This difference in reflectivity raises questions about the processes that led to such a difference in composition. One hypothesis is that Kerberos's surface is covered in organic compounds, similar to tholins. Another possibility is that Kerberos's surface is composed of materials rich in carbon or other dark rocky materials. Determining the exact composition of Kerberos remains a challenge due to its small size and faintness. Future observations with more powerful telescopes may shed more light on this enigmatic moon's makeup. Despite its size, Kerberos exerts a gravitational influence on its neighboring moons. This interplay provides valuable information to astronomers studying the dynamics of the Pluto system. Kerberos contributes to the orbital resonances observed among Pluto's moons. Its gravity helps maintain these resonances, keeping the moons in their intricate orbital dance. By studying these resonances, astronomers infer the masses of the participating bodies. Gravitational interactions between Kerberos and its neighbors provide insights into the history of the Pluto system. Kerberos and its fellow moons are thought to be products of a cataclysmic event billions of years ago. A large object is believed to have collided with Pluto, ejecting debris into orbit. This debris gradually coalesced, forming the smaller moons we observe today. Kerberos's irregular shape suggests it formed from the merger of two smaller bodies. This collision scenario explains the orbital resonances and peculiar characteristics of the Pluto system. By studying Kerberos, scientists hope to learn more about the early solar system and the processes that shaped it. A cosmic puzzle, reconstructing the Plutonian moon system. The discovery of Kerberos forced scientists to re-evaluate their models of the Pluto system. Kerberos's inclined and eccentric orbit suggests a more chaotic and eventful past. Gravitational interactions with Charon and collisions with unseen objects could have perturbed its orbit. Astronomers aim to reconstruct this complex history by studying the orbits, compositions, and surface features of Pluto's moons. By piecing together these clues, scientists hope to paint a more complete picture of the Pluto system's evolution. Brightness. Paradox. Explaining Kerberos's unexpected dimness. Kerberos's dark surface contrasts with the brighter surfaces of Nix and Hydra. This discrepancy raises questions about their shared origin. One hypothesis is that Kerberos's smaller size and weaker gravity make it difficult to retain volatile ices. Another possibility is that its surface has been darkened by the accumulation of organic compounds. These compounds could have gradually coated Kerberos, giving it its characteristic dark hue. Section 4. Future Missions. Unlocking the Secrets of Kerberos and Beyond. The New Horizons flyby of Pluto in 2015 revolutionized our understanding of these distant worlds. However, many questions about Kerberos and its companions remain unanswered. A dedicated mission to the Pluto system is needed. Such a mission could resolve the mystery of Kerberos's dark surface. By studying the light, scientists could determine the abundance of various materials. A mission could also study the gravitational interactions between the Plutonian moons. This information would refine models of the system's formation and evolution. Beyond Kerberos, exploring Pluto's other moons holds immense scientific value. Each moon helps us understand the formation of planetary systems and the diversity of worlds. The exploration of the Pluto system is far from over. It is a journey of discovery that promises to captivate our imagination for generations to come. Kerberos, the Chaotic Choreographer. In the Pluto system, Kerberos, though small, plays a surprisingly influential role. Its presence introduces a touch of chaos into the otherwise predictable dance of the moons. This chaos acts as a subtle choreographer, shaping the system's dynamics. Imagine the Pluto system as a synchronized clock, each moon moving with precision. Now introduce Kerberos, a tiny pebble disrupting the gears. Its presence disrupts the perfect order, introducing slight variations in the moon's orbits. These variations, over millions of years, profoundly impact the system's evolution. A delicate balance. Kerberos' role in orbital stability. While Kerberos' gravitational influence introduces a degree of chaos into the Pluto system, it also plays a crucial role in maintaining the system's overall stability. This seeming paradox highlights the intricate and often counterintuitive nature of celestial mechanics, where seemingly disruptive forces can, in fact, contribute to long-term equilibrium. Imagine a group of acrobats balancing on a high wire. Each acrobat's movement, though seemingly independent, affects the balance of the entire group. Similarly, in the Pluto system, the gravitational pull of each moon, including tiny Kerberos, contributes to the overall balance of the system, keeping the moons from straying too far from their current orbits. Kerberos's role in this delicate balancing act stems from its position within the system. Situated between the orbits of Nix and Hydra, Kerberos acts as a gravitational buffer, its weak pull counteracting the stronger influences of Pluto and Charon. This delicate interplay of gravitational forces prevents any single moon from dominating the system, ensuring that the moons remain locked in their intricate orbital dance. This balancing act is not static. Over vast timescales, the orbits of Pluto's moons do evolve, albeit very slowly. However, the presence of Kerberos, acting as a gravitational anchor, prevents drastic shifts in their orbits, ensuring the system's long-term stability. This delicate balance is a testament to the elegant and often surprising ways in which gravity shapes the cosmos. Tidal forces, shaping Kerberos' fate. The gravitational dance between Pluto, Charon, and their smaller moons doesn't just affect the orbits of these celestial bodies. It also generates tidal forces that can have a profound impact on their physical shapes and internal structures. Kerberos, despite its small size, is not immune to these tidal forces. In fact, they may hold the key to understanding the moon's peculiar double-lobed shape. Imagine a rubber ball being squeezed from opposite sides. The ball will deform, bulging out along the axis of compression. Similarly, tidal forces, arising from the difference in gravitational pull across a celestial body, can stretch and squeeze moons, shaping their appearances over time. In the case of Kerberos, the combined gravitational pull of Pluto and Charon generates tidal forces that are strong enough to deform the moon. These forces, acting over billions of years, could have elongated Kerberos, pulling it into its current elongated shape. This tidal stretching could also explain why Kerberos is less spherical and more irregular in shape compared to some of its neighboring moons. The internal structure of Kerberos is also likely influenced by tidal forces. If Kerberos is composed of a mixture of ice and rock, as suspected, the constant stretching and squeezing caused by tidal forces could generate heat within the moon. This tidal heating could have significant implications for the moon's geological activity, potentially leading to internal melting and resurfacing events in the past. Section 4. Unveiling the Secrets, Future Observations of Kerberos Interactions. New Horizons provided invaluable data, but many questions remain. Future missions with advanced instruments are needed to unravel Kerberos' mysteries. Key goals include measuring Kerberos' orbit and tracking its position. This helps map gravitational interactions and refine Pluto system models. High-resolution images and spectroscopic data are also priorities. These reveal surface features and composition, providing clues about Kerberos' history. Section 1. A window into the Kuiper belt. Kerberos as a planetary building block. Kerberos, though a small and seemingly insignificant moon orbiting a distant dwarf planet, holds profound significance for our understanding of the solar system's formation and evolution. This tiny moon, a relic from the early days of our solar system, provides a unique window into the composition and dynamics of the Kuiper belt, a vast and icy region beyond Neptune that is home to countless remnants from the solar system's formation. Imagine the early solar system as a swirling cloud of gas and dust, a chaotic nursery where planets were born. Within this cloud, small icy bodies, like Kerberos, coalesced from the primordial material. These planetesimals, the building blocks of planets, aggregated over time, forming the planets and moons we observe today. The Kuiper belt, a vast and sparsely populated region, preserves a pristine record of these early planetesimals. Unlike the inner solar system, where the intense heat and gravitational influence of the Sun have altered the composition of celestial bodies, the Kuiper belt has remained relatively unchanged for billions of years. Kerberos, as a resident of this pristine region, offers scientists a glimpse into the composition of the primordial material from which our solar system formed. By studying its surface composition, density, and internal structure, astronomers can glean valuable insights into the building blocks of planets and the conditions that prevailed during the solar system's infancy. Section 2. Testing the Limits. Understanding Planetary System Formation. The study of Kerberos and the Pluto system as a whole provides a unique opportunity to test and refine our models of planetary system formation. The traditional model, based on observations of our own solar system, suggests that planets form in a relatively orderly fashion, with larger planets forming in the outer regions and smaller rocky planets forming closer to the star. However, the discovery of exoplanets, planets orbiting other stars, has challenged this traditional view. Exoplanet systems often exhibit wildly different architectures than our own, with gas giants orbiting close to their stars and planets existing in highly eccentric orbits. The Pluto system, with its complex orbital dynamics, its diverse collection of moons, and the evidence for past collisions, suggests that planetary system formation is a far more chaotic and complex process than previously thought. The presence of Kerberos, with its inclined and slightly eccentric orbit, adds further weight to this view, suggesting that gravitational interactions and collisions play a significant role in shaping the final architecture of planetary systems. By studying the Pluto system in detail, astronomers can develop more sophisticated models of planetary system formation that can account for the wide range of planetary systems observed in the universe. These models will help us to understand not only how our own solar system formed, but also the conditions that lead to the formation of planetary systems around other stars. Section 3. Small Moon, Big Impact, Kerberos's Contribution to Science. Despite its diminutive size, Kerberos has had a significant impact on the field of planetary science. Its discovery, along with the other small moons of Pluto, has forced astronomers to rethink their understanding of the Pluto system and its place in the solar system. Prior to the discovery of Kerberos and its companions, Pluto was often viewed as a simple system, a lone dwarf planet with a single large moon, Charon. However, the discovery of these smaller moons revealed a far more complex and dynamic system, one shaped by collisions, gravitational interactions, and the subtle interplay of orbital dynamics. Kerberos, with its peculiar characteristics, has played a key role in this paradigm shift. Its dark surface, its irregular shape, and its inclined orbit all point towards a complex and chaotic past, one that challenges our assumptions about the formation and evolution of planetary systems. The study of Kerberos has also highlighted the importance of continued exploration, even of seemingly insignificant celestial bodies. Often, it is the smallest and most unexpected discoveries that lead to the biggest leaps in our understanding of the universe. The exploration of Kerberos and the Pluto system is far from over. The New Horizons flyby, while groundbreaking, provided only a fleeting glimpse of these distant worlds. Future missions, equipped with more advanced instruments and designed for longer duration observations, are needed to fully unravel their secrets. Imagine a future spacecraft, specifically designed to study the Pluto system, orbiting the dwarf planet and its moons for years, meticulously mapping their surfaces, analyzing their compositions, and studying their interactions in unprecedented detail. Such a mission would revolutionize our understanding of these distant worlds, providing a wealth of data that would keep scientists busy for decades to come. Future observations of Kerberos could focus on determining the composition of its dark surface, searching for evidence of past geological activity, and studying its interaction with the other Plutonian moons in greater detail. These observations could help to determine whether Kerberos is a captured object or a true native of the Pluto system, providing valuable insights into the formation and evolution of this distant world. The exploration of Kerberos and the Pluto system represents a journey into the uncharted frontiers of our solar system, a realm of icy bodies, dwarf planets, and remnants from the solar system's formation. Each new discovery in this distant realm expands our understanding of the cosmos and our place within it. Kerberos, a diminutive moon in the Pluto system, stands as a testament to the boundless capacity for discovery in the cosmos. Though small and distant, its existence challenges our notions about planetary systems, reminding us that the universe is full of surprises. Imagine this tiny moon, a mere speck of light, holding secrets of a tumultuous past. Its irregular shape hints at a history marked by collisions sculpted over billions of years. Its dark surface contrasts with its brighter siblings, raising more questions than answers. What is the composition of this shadowy world? Does it harbor organic molecules or primordial materials? Kerberos, though minor, influences the Pluto system's dynamics. Its presence introduces chaos, preventing predictable patterns. Studying Kerberos extends beyond understanding a single moon. It helps us understand planetary systems, gravity, and cosmic collisions. The Kuiper Belt, a vast and icy realm beyond Neptune, holds a record of the solar system's earliest days. This distant region offers a glimpse into early planetary formation. Imagine a swirling cloud of gas and dust, where planetesimals collided and coalesced, forming the worlds we observe today. The Kuiper Belt preserves a pristine record of these early planetesimals, frozen in time for billions of years. By studying Kuiper Belt objects, scientists hope to unravel the mysteries of planetary system formation. The Kuiper Belt promises to revolutionize our understanding of planetary systems and the potential for life beyond Earth. Kerberos, a tiny moon orbiting a distant dwarf planet, serves as a powerful reminder of the enduring allure of exploration, the insatiable human desire to venture into the unknown and unravel the mysteries of the cosmos. The exploration of Kerberos and other distant worlds is not merely an academic pursuit, a quest for knowledge's sake. It is a testament to the human spirit and inspires future generations to reach for the stars. The story of Kerberos is far from over. Future missions will undoubtedly reveal even more secrets hidden within this enigmatic moon and its companions. Kerberos, a tiny sentinel in the vast expanse of space, stands as a beacon beckoning us to continue our exploration of the cosmos, to embrace the unknown.